As part of variance test, once again you need to compose null and alternate hypothesis. Remember, we are dealing with the purchases made because of full interest rate waiver, and we are dealing with purchases made because of standard Christmas promotion. Yeah. So as part of variance test, that is, are variances equal or not, we need to check whether variance of purchases because of full interest rate waiver is equal to variance of purchases made because of standard Christmas promotion, or variances because of full interest rate waiver, is it not equal to variance of standard Christmas promotion? This is what you need to test. Why am I using sigma square here? Because that is a simple symbol for your population variance. And we have already discussed that when we perform hypothesis testing, we need to first compose hypothesis testing based on population parameters. Though we will work on a sample, when we compose hypothesis, we always need to consider population parameters. All right. So this, we're going to write on that Word document and proceed further. So the next test here is variance test. And we need to first, we need to first write down null and alternate hypothesis. Null hypothesis says variance of purchases made because of full interest rate waiver is equal to variance of purchases made because of standard Christmas promotion and alternate hypothesis says variance of purchases, I'll copy this part, is not equal to variance of purchases made because of standard Christmas promotion. Okay. Once again, if your management walks up to you and says they want you to come up with 95% confidence, right? They want you to be 95% confident with your results, then that is fine. But if your management does not ask you anything, then it is safe to conclude alpha value as 5% and 1 minus alpha is 95%, because this is the industry norm. Statisticians, mathematicians have done umpteen number of experiments till now, and based on that they conclude that these values are the safest bet for you. So once again, we need to write this, that p-value, yeah, fine. So let us do this test and then try to see what is the p-value, post which we'll proceed further. So here is our data set. If you click on this, you'll go back to your worksheet. We need to go to stat, basic statistics, and here you see two variance test. I click on that. Each sample is in its own column. Full interest rate waiver sample is in one column. Standard Christmas promotion is in its own column, right? So each sample is in its own column. Full interest rate waiver. Okay, so initially when you open, you'll not see anything there because, yeah. So full interest rate waiver is sample 1 because it's here in the first column, and then sample 2 is standard promotion. Now if I simply click on OK, I have to look at Bonnett's test p-value, which is 0.662. Forget about Levene's test, I'll explain in a moment from now. But Bonnett's test is p-value corresponding to that is 0.662. So p-value is 0.662. This p-value is greater than 0.05. What does that imply? P high, null, fly, which implies you're going to accept null hypothesis. What does your null hypothesis say? Variance of purchases made because of full interest rate waiver is equal to variance of purchases made because of standard Christmas promotion. So both the variances are equal. That is what your hypothesis test has told you here. All right. So we look into Levene's test. If data was not normal, and if you would have still proceeded assuming that data are normal, right? In this scenario, statistically using hypothesis testing, we assume that data are normal. But if data are not normal, and if you still proceed assuming that data are normal, then you look into Levene's test p-value. Otherwise, you need to look into Bonnett's test. Different scientists have come up with different ways of calculating p-values. Yeah. All right. Now, if variances are equal, yes, variances are equal. This test has told that yes, variances are equal. If variances are equal, we compare means using two sample t-test, assuming equal variance, because we have proven that variances are equal.